let's talk about symmetrical and skewed data, how they compare. So first off, I kind of just want to talk about axes, right? When we're talking about a graph, you've got the x-axis on the horizontal and the y-axis on the vertical. Now, in general, not always, but a lot of times, the x-axis is going to talk about time. And it always starts with the least on this side and it gets bigger and it goes up to the greatest, right? Least to greatest. Same thing. Forgot how to spell there for a minute. Same thing on the y-axis, that you go least to greatest, but this usually gives the frequency or the count. How many times does something happen? And that's kind of important and crucial across all graphics and mathematics, that the x-axis, if you are talking about time, that's represented on the x-axis, and the y-axis talks about how many times something happens. Okay, now talking about graphs, first of all, we're talking about symmetrical. Symmetrical simply means if I cut it down the middle, it's going to be equal on the left and the right sides. Right? Well, in terms of our data and our descriptive statistics, the mean, the median, and the mode are all the same, and they all lie on that middle line, which the mode makes sense. That's the highest point. But the mean and the median will also be there, and they are all equal. So that's symmetrical data. Now, I talked about bimodal. If you watched my mode video, I talked about bimodal, meaning we have two modes. Well, you can see in this graph that we have two that have the equal heights, right? So the mean and the median would still fall directly in the middle, the mean and the median. But in this case, we have two modes that fall at the top of each peak. And since they're equal, we have bimodal, right? This doesn't happen a ton, but it is possible. We call this symmetrical because the mean and the median are still the same in the middle, and again, the left and the right side are equal. Now, most of the time, we don't have symmetrical data, right? That's living in a fantasy land. So our first skewed option is skewed left. The way I remember this graphically is when I look at the curve, which way am I sliding? In this case, I'm sliding left, so it's skewed left. Most of the data lies on the right, which causes me to slide down the slide to the left. We also say, in general. That means not always, but a lot of times, if you have it skewed left, that means the mean is going to be less than the median. It's because these low numbers are going to drag the mean down, while the median remains in the middle of the data. So in general, if you are skewed left, the mean is less than the median. So if you're sliding left, the mean is less. Right? So we talk about the mean being first. Now, similarly, when we're talking about being skewed right, you'll see graphically I'm sliding down the right, which means my mean, in general, will be greater than the median. Because again, these large numbers are going to bring up my mean, while the median remains in the middle. So, I slide right, my median is greater. The way you slide is the way your inequality symbol points when you're talking about this general theory that the mean and the median are related in terms of skewness. Let's talk about some problems now. Normally, we expect the elderly to die, but not the young. Since more elderly people die than the very young, is age at death skewed left or right? So we're talking about age, and in this case, the number of deaths. Remember how I said time always goes on the x-axis? Well, age is a measure of time. So we're talking about super young people over here, super old, okay, 80 is not super old, but old people on the right, and then these are, how many people are dying. Great. Well, we expect the elderly to die. If I've got a room and half of them are 80 and half of them are 0, I expect the 80-year-olds to go first, right? So we expect way more people to die over here, and the younger they go, the less of them die. So by looking at this, I'm sliding to the left, so I would say this is skewed left. Right? I am a pictorial person. I need to see, I need to visualize. And that's why I draw these graphs out for these problems, because that allows me to see the problem that I'm working with. All right, let's go to number 6. Oops, nope, page 6, number 2. How are the ages of Ivy Tech students distributed in this graph? Which would we expect to be greater, the mean or the median? Now, if you take these bars and you make them a curve, what do you notice? Well, high numbers are over here, and I'm sliding to the right. So we would say this is skewed right. And if I'm going to the right, that means I'm opening this way. We would expect the mean to be greater than the median, because these upper-aged individuals, which tend to be, in my experience, really fun to work with, those ages are going to drive up the mean while the median remains in the middle. So the mean generally will be greater than the median. Number 3, this dot plot shows the distribution of the data set from number 2 in the mode page. So if you watch the mode video, you calculated this information. Does the data appear to be skewed? Okay, well, when you have a dot plot or a graph and you're not sure, find the tallest bar. Okay, so here's my tallest bar right here. If I go to the left, I've got 2 spots, right? 1, 2. But when I go to the right, I have 1, 2, 3, 4. Since I have more spots on the right, it's definitely skewed right. And that's how you can tell. Start with your highest bar, and then how many bars do you have on each side? That's how you can tell skewness. So we expect skewed right means we expect the mean to be greater than the median, right? This is what, oops, I spelled wrong. This is what we expect. If you go back to the mode page a few pages ago, you would see the mean is 3.4 and the median is 3. So it holds true that the skewness of the graphic matches the data because 3.4 is greater than 3, and that all works out fine. This should be number 4. We've got a numbering issue. Number 4, we've got 8 numbers here. What is the mean of these scores? This is exam scores. Obviously, we had 2 people who didn't show up. So the mean, well, the mean says we add all of these together. When I add them, I get 447, and I have 8 scores total. So if I add them all together, you get 447 divided by 8. The mean score is 55.875. Now, as an instructor, I'm freaking out if my average score is 55.9, right? That's an F. And that just makes you feel really, really bad about yourself as an instructor. Well, it should. If you don't have a heart. Anyway, that's a whole different can of worms. What's the median? Well, if we cross out the 3 on the top, 3 on the bottom, there's my median. I take the add these 2 together. I get 147 divided by 2, and my median is 73.5. Well, that's a C. As an instructor, I'm happy with that. If the median is a 73.5, that's not bad at all, right? So when you're looking at this, the 2 students, part C, the 2 students who received zeros are causing the data to be skewed. How is it distributed? Well, when we're comparing the mean to the median, the mean is 55.9, I rounded. The median is 73.5, so the mean is less than the median. This is skewed left. And if you think about it, looking at letter D, which value, the mean or the median, is a better representation of this data? Well, hands down, the answer is the median. When you look at having an average score of 55.9, you get a 55 and 2 zeros. Those are the only numbers less than a 55.9. And 55, that's about right on. However, the rest of these students, right, more than half of the students, did fine on the exam. So it's not, you can't use the 55.9 to say you're a horrible instructor. No, I'm not. I had 2 people who just bailed on me and didn't come. So, you really have to pay attention to the mean and the median. The mean does not always give you a fair representation of the data. These, we call them outliers, really are going to drag values either down or up depending on your data set and can really mess up the information. So in this case, the median is by far a better representation of these 8 scores on the exam.